Hello students, good morning. I hope you all are safe and healthy at your home. In last lecture, Unit 2 Synthetic Drugs, paper number ICH-CC-506, we started unit number 2, and in this unit we studied about the classification of drugs. In this unit, we have also some classes of drugs like anti-TB, anti-leprotic drugs, anti-diabetic drugs, anthelmintic agents, and antiseptic drugs. In this lecture 2, we studied about this class of the drugs. In this lecture, we starting from the anti-tubercular drugs or anti-TB drugs. First of all, we see introduction, and then in this class we have two drugs. So we show the synthesis and its usefulness or medicinal applications. So we start with the introduction of anti-tubercular drugs, or in short anti-TB. Tuberculosis is as old as mankind. It is a systemic infectious disease which is caused in men by organisms such as Mycobacterium tuberculosis and Mycobacterium bovis. These two names, Mycobacterium tuberculosis and Mycobacterium bovis, both two are bacteria which cause the TB. About 1 to 2 million people die every year due to this disease. Please note this. About 1 to 2 million people every year. Tuber cell bacilli have been found to affect any organ or tissue in the body, but the most common is tuberculosis of lungs. And we also, this tuberculosis of lungs, we also hear about in our society. The disease may vary in intensity from the latent tuberculosis, which does not show any change over a prolonged period of time, but is incompletely healed and potentially active, to the acute generalized to tuberculosis, in which the bacteria are widely distributed in large numbers throughout the body, and which without treatment is rapidly fatal. According to R.H. Ebert, this is the name of scientist, R.H. Ebert, in 1955, an ideal chemotherapeutic agent in tuberculosis. We see this class or classification of chemotherapeutic agent, and in this classification the word anti-tubercular. So according to the R.H. Ebert in 1955, an ideal chemotherapeutic agent in tuberculosis should have the following properties. Some properties is described here. Number 1, it must be bactericidal or bacteriostatic in relatively low concentration. Both the definition we studied in past lectures, bactericidal and bacteriostatic. It must always be able to accomplish this without the development of bacterial resistance. Number 2, it must be highly diffusible and be able to reach all tissues, including the meninges, and brain. It should be able to penetrate vascular, necrotic, and sufficiently high concentration to have an effect on the tuber cell bacillus. As number 3, as tuber cell bacilli may survive and multiply within mononuclear cells, it must be able to penetrate the cell membrane. Number 4, mere availability of the drug is not enough. However, because it must be effective in a variety of biochemical environments, especially that which prevails within the caseous or neurotic lesions. And number 5, it must also be effective against organisms which exist in a variety of metabolic states, ranging from organisms actively divided into those which appear dormant. Number 6, it must be relative non-toxic in therapeutic doses, and toxicity must remain low even when the drug is given for protected period. And last, number 7, finally, it must be relatively stable for reasonable lengths of time and not excreted too rapidly for a alter so quickly by the host that it is impossible to obtain therapeutic levels. So this is the property of anti-tubercular drugs. No drugs so far known satisfy the above requisite completely. And the different chemotherapeutic agents used for the treatment of tuberculosis are follows. Today, these all are used in the different way in tuberculosis. Para-amino salicylic acid, isoniazid, pyrazinamide, ethionamide, ethambutol, cycloserine, viomycin, and number 8, rifampin. These are all non anti-tubal or anti-TB drugs. And according to our syllabus, we have studied only two drugs. Number 1 is para-amino salicylic acid, PAS, and number 5, that is the number 2 of our syllabus, is ethambutol. So, in this lecture, we synthesize these two drugs, para-amino salicylic acid and number 2, ethambutol. We first of all start with the para-amino salicylic acid. Synthesis of para-amino salicylic acid. It is also known as PAS, PAS. Para-amino salicylic acid is synthesized from anthranylic acid. Here, given structure is anthranylic acid. In one carbon is attached with NH2 and number second is attached with carboxylic acid. So this is the structure of anthranylic acid. On the nitration, in presence of concentrated nitric acid and sulfuric acid, it gives the yield 4-nitroanthranylic acid or para-nitroanthranylic acid. If we number give, it is from COOH carbon content number 1 1, 2, 3 and 4. So it is the 4-nitroanthranilic acid or ortho. This is ortho, meta and para. So it is also known as 4-nitro or para-nitroanthranilic acid. On treatment with NaNO2 and HCl, 4-nitroanthranilic acid is converted into diazonium salt. Diazonium salt. Treatment or reaction with NaNO2 is converted NH2. This is the NH2. NH2 is converted into N double bond and Cl is also joined with. So N2Cl or N double bond and Cl is known as diazonium salt, diazonium chloride. So this is the we get yield is diazonium salt of 4-nitrobenzoic acid. Now, this 4-nitrobenzoic acid, diazonium salt of 4-nitrobenzoic acid is treated with boil water. So, this is the N double bond and Cl group. Diazonium chloride is converted into OH and finally we get 2-hydroxy 4-nitrobenzoic acid. 2-hydroxy 4-nitrobenzoic acid. Now we treated this 2-hydroxy 4-nitrobenzoic acid with acid metal reduction Sn plus HCl in presence of tin and hydrochloric acid. The nitro group NO2 is converted into NH2 and finally we get 4-amino 2-hydroxybenzoic acid. 4-amino 2-hydroxybenzoic acid. This 4-amino 2-hydroxybenzoic acid is also known as para-amino salicylic acid and in short we also say as a PAS, para-amino salicylic acid or PAS. So this is the synthesis of para-amino salicylic acid from anthranic acid. Now, medicinal application of para-amino salicylic acid. This compound was first proposed by Lehman, the scientist, in 1964 for the treatment of tuberculosis. After this, it was widely used both alone and with antibiotics in the treatment of the disease. Many attempts were made to modify this compound, but all these attempts proved futile because the majority of new compounds are inactive. Therefore, this compound is still para-amino salicylic acid is still very important in treatment of tuberculosis. It is bacteriostatic and stop the growth of actively multiplying tubercular bacilli both in vivo and vitro. Please note that both in vivo and vitro. So para-amino salicylic acid is very important in vivo and vitro. It is readily absorbed on oral administration. A solution of sodium salt is being used for intravenous infusion. Treatment has to be continued for 3 to 6 months. The main use of para-amino salicylic acid is that it delays development of resistance to tuberculotic drugs. The portable mechanism of the action of these drugs is that it interferes with utilization of para-amino benzoic acid, a vitamin of B group, by tubercular bacilli. And last point, the toxic effect of para-aminosalicylic acid is that it tends to cause gastrointestinal disturbance with occasional skin rashes. There is only few side effects. One is gastrointestinal disturbance and other is skin rashes on some peoples. This is the synthesis and medicinal application of first anti-tubercular drug para-amino salicylic acid. And according to our syllabus, second compound is ethambutol. Ethambutol. It is also known as anti-TB drugs. Ethambutol is prepared from 1-nitropropane. Here described structure is 1-nitropropane. This 1-nitropropane is treated with methanol, HCHO, methanaldehyde, methanol, in presence of alkali sodium hydroxide. So 1-nitropropane, methanol and sodium hydroxide are converted into 2-nitrobutanol. We get product 2-nitrobutanol. This 2-nitrobutanol is treated with metal acid Fe plus H2SO4 in presence of calcium hydroxide. So 2-nitrobutanol in presence of Fe, H2SO4 and calcium hydroxide is converted into 2-aminobutanol. Here acid metal reduction takes place. Acid metal reduction takes place. So this NO2 group is converted into NH2 group. Now we see the next step. First synthesize 2-aminobutanol. 2 moles of 2-aminobutanol is treated with 1,2-dichloroethane. This is the structure of 1,2-dichloroethane. Interaction between 2 mole of 2-aminobutanol and 1,2-dichloroethane gives ethambutol. We see the detail. From 2-aminobutanol, one hydrogen from here and one hydrogen from here, and 2 chlorine, 1,2-dichloroethane, 2 chlorine, Cl from here and Cl from here, and remove 2 HCl and condensation takes place and we get ethambutol. And chemically, ethambutol is also known as 2-amino-2-ethyl for 1-hydroxymethyl propyl amino-butane 1-ol. I repeat the name, 2-amino-2-ethyl for 1-hydroxymethyl propylamine butane 1-ol, or it is known as ethambutol. So this is the synthesis of ethambutol. In this synthesis, first of all, we synthesize 2-amino butanol, and then it is treated with 1,2-dichloroethane. We get yield ethambutol. Now the medicinal application of ethambutol. It is usually used as dihydrochloride and given orally. And last, number 2, it is generally given along with other anti-tubercular drug for the treatment of pulmonary tuberculosis. This is not that it is particularly used for pulmonary tuberculosis. So in this class we studied in this lecture two drugs, para-amino salicylic acid and ethambutol. So here I finish this lecture and we complete in this unit our first groups of drugs, anti-tubercular or anti-TB drugs. Thank you.